Okay, what we have here is a 1950 crane sink with Dial-Ese faucet. The Dial-Ese is a very durable and popular faucet cartridge, but it has some problems. For one thing, if you turn on the hot water, watch the flow decrease as the water heats up. You can already see the water stream getting narrower. You add a little more. But as the water continues to heat up, that stream's going to continue to get slower and slower. You have to keep opening the valve a little more each time. It's because it's an all-metal cartridge, and the hot water heats the metal. The metal expands and closes the gap through which the water passes. Also, because of the way the valve is designed with a spiral opening, if you happen to catch the handle just wrong, you get this kind of chattering, which under the right circumstances, or I should say the wrong circumstances, can be very loud, annoying noise. If you're using the washroom late at night, you don't want to wake other people up. That's a little bit of a disadvantage. Now I've got two Dial-Ese cartridges in my hand here. This one is an original type cartridge, and you can see right up here, you can see that spiral thread. That's how it opens. You can see that stem move down as I turn it open, and move up as I turn it closed. And down here at the bottom end, that's normally hidden from view, you can see as I open it, that stem moves down and creates a gap for water to enter at the bottom, proceed through the valve, and out the side here, where it's routed to the spout. That's why on the hot side, if you open it just a little bit with the valve cold, the hot water heats up the valve, and the gap effectively closes as the metal expands, and you have to keep opening the valve. This is the only type that was available for many years. The original type, you can see it's got a rubber seal there at the bottom for the seat. Now, there's a new type available. It's this kind, and it looks very different. There's no spiral up here. There's no stem down here. Instead, turning this, it stays on the same level. It does not spiral. And down here what you can see is two ceramic discs that sort of counter-rotate to open or close a gap up inside the valve, so water will flow again through the bottom of the valve and out the side and into the spout. The nice thing about a ceramic valve like this, it'll never corrode because ceramic will not corrode, and it's got a nice quarter turn action, so that you don't have a large amount of valve spinning to do to go from full close to full open. It's just a quarter turn with a definite stop at the closed position and the full open position. These are new from DEA Bath, and they are actually made in America, which is a nice bonus, difficult to find these days. Now the first step is obviously to turn off the water valve under the sink. That's very important if you don't want to wet down the whole washroom and cause a flood. Whenever you do that, do be careful, because often those valves are not used for years at a time. They can corrode internally. Turn it carefully at first to make sure there's no dripping. At the very least, you may want to put a bowl under it to collect whatever drips do happen. This has already been turned off, so we use a flathead screwdriver to remove the screw holding the handle. It's good to use a nice big screwdriver that exactly fits the screw slot, otherwise the screwdriver could slip and mar the screw. Does anybody say mar anymore? Remove that screw, remove the handle. These handles, the old crane handles, were made out of zinc die cast, which takes a nice chrome plate and is inexpensive to work with, but it's also not very corrosion resistant. You can see the underside of this handle has a bunch of white powdery corrosion in there. Eventually it will need replacing. This one is 63 years old, and it's still got some life left in it. You can see this square part here is still intact. It's still good solid material there. It's not powdered yet. We set this aside. Next you have the handle adapter, which is this square piece of either white nylon or brown fiber-filled phenolic material. Now you can see the top of the valve. In order to remove the valve, first you have to remove the cap nut. I'm using an adjustable wrench here, which is not really quite proper procedure. I ought to have the proper sized wrench, but I don't. So I'm going to carefully use this adjustable wrench to turn the cap nut counterclockwise, just like that. Unscrew that. And I should note, this is not the original 50-odd, 60-odd year old valve in this sink. This has had periodic replacements over the years. Now all you need is a 9/16 open-end wrench to grab the flats on the valve and just unscrew it right out of there. Very easy. You'll see water will well up a little bit if your under-sink valves don't seal quite as well as they should. This particular valve is not very old. This one's about a year old. You can already see some green, very beginnings of corrosion here. That's really of no consequence. After several decades, they do get kind of crusty. Now take note, there's a cap nut washer here. This one's made out of black rubber. Another type you may see is a combination cork rubber particulate material here. Now when you're replacing Dial-Ese faucets, take note, they come in two varieties, a hot and a cold, and the difference is which way you turn the valve to open it. A sink like this with round handles uses two hot valves, a hot valve here and a hot valve here. Those turn counterclockwise to open, to turn on the water, clockwise to close, turn off the water. If you have a sink that has lever type or flag type handles, you use a hot on this side and a cold on this side so that you can grab the levers or the flags and pull them inwards towards the sink bowl to open. So we have our new type ceramic valve. And we'll just thread that in there. You notice how the water welled up due to the not quite completely closed under sink valve when I took out the old valve. That actually saves me a step. If the under sink valve had sealed completely, I would have wanted to go under there with the valve removed from up top, go under the sink and just slightly crack the supply valve to let some water flush through, so then any particles, any pieces and parts, chips and chunks, grits and granules that might have been knocked loose when I removed the old valve will be flushed out so they don't clog the new valve. So now we use our 9/16 inch end wrench to snug that valve down. And you don't need to be the Incredible Hulk about it. You want to get it nice and snug, but don't cram it in there. You got a rubber seal at the bottom of this valve that just needs to make a good seal down at the bottom. Now I'm going to use a sponge to try and soak up this water that kind of filled this little trough here when the water welled up, because that would have a hard time evaporating. It's kind of a shielded location, and I don't really want water sitting there in the vicinity of a zinc die-cast handle that already has some corrosion on it. So we just wipe up that water out of there, give that a bit of a wipe. There we are. I'm going to go ahead and reuse the black rubber cap nut washer. Just push that down, grab the cap nut, thread that on. It's best to start threading by hand, that way if the threads cross or don't engage correctly, you have the chance to back it off and start again without ruining the threads. Don't ruin the threads, it'll spoil your day. It'll mar your day. There, I said mar twice. So tighten the cap nut. Here again, you don't need to be a He-Man about it, just get it properly snug. Got your handle adapter, that goes on this splined top of the valve here. And then the handle. And then the handle screw. It's best to hold on to the handle while you tighten the screw. And there we are. Now we have this nice, very nice quarter turn operation with a nice positive firm click stop at each end, closed and open. Let's turn on the valve under the sink. Okay, I've turned the water back on under the sink, And now I can open the valve, the hot valve just slightly there. And the water's warming up and the supply doesn't change. It no longer restricts the flow as the valve heats up. If I want a little more flow, I can do that. As the water carries on heating up, that flow stays the same. That's a big improvement. There's no longer any possibility of chatter. This is not moving up and down. There's no axial movement at all. If I want full flow, I can get full flow. There it is. And it closes off nicely. This is just all around a much nicer, much better valve. They are more spendy. You can get the original style valve stems. You can get cheaper Chinese or Taiwanese made ones for $6 or $7. If you scratch around, you can find American or Canadian made ones for maybe twice that, $12 to $15. These new ceramic type valves are rather costly. They're about $29 a piece. But by every indication from my scrutiny, I can't imagine ever having to replace that valve again as long as I have this sink in operation. I'm planning on having it in operation for the foreseeable future. So there it is. That's how to service a Crane Dial-Ese valve, whether you're installing an original type valve or the nifty new ceramic type valve from DEA Bath. That's how it's done. Very easy.